So 5-2 probability rules. The idea of probability rests on the fact that chance behavior is predictable in the long run. In section 5.1, we use simulation to imitate chance behavior. Do we always need to repeat a chance process many times to determine the probability of a particular outcome? Fortunately, the answer is no. All right, in chapter 2, we saw that a normal density curve could be used to model some distributions of data. In chapter 3, we modeled linear relationships between two quantitative variables with least squares regression line. Sorry. Now we're ready to develop a model for chance behavior. Let's start with a very simple chance process. Tossing a coin once. When we toss a coin, we can't know the outcome in advance. What do we know? We are willing to say that the outcome will either be heads or tails. We believe that each of these outcomes have a probability of 1/2 or 0.5. This description of coin tossing has should say two parts. The first one is a list of possible outcomes. This is called the sample space. You need to know what that is. And it's denoted with a big S. And then the probability for each outcome. Such a description is the basis for a probability model. Here is the basic vocabulary that we use. The sample space, again, using that big S, of a chance process is the set of all possible outcomes. And again, these are things that you need to know, these two things. A probability model Perfect. Thank you. If anybody wants food while I'm doing that, I think so. Sorry, guys, hang on. He's been kicking people out today, so it wouldn't surprise me if he was in here and then got kicked out. It's been all day today. All right, a probability model is a description of some chance process that consists of two parts, a sample space and a probability for each outcome. A sample space can be very simple or very complex. When we toss a coin once, there are only two possible outcomes, heads and tails. So that would be a very simple sample space. We can write the sample space using set notation. as S is equal to, and those are curly brackets, HT, because those are the only possible outcomes you can get. When Gallup draws a random sample of 1523 adults and asks a survey question, the sample space contains all possible sets of responses from 1523 of the 235 million adults in the country. So this sample space would be extremely large because there's a big number of them. Each member of the sample space, and again, I'm just putting the S for sample space, lists the answer for one possible sample, which explains the term sample space. Okay. So let's look at how to set up a probability model in a familiar setting, rolling a pair of dice. So many board games involve rolling dice. Imagine rolling two fair six-sided dice, one that's red and one that's green. Give a probability model for this chance process. You guys have seen this before, you just don't realize you have. So this is what you're going to do. You just make a big chart. Your possible outcomes. And we're not going to do the full chart. Just bear with me till you understand it, okay? This one is going to be your green die. Six-sided red die. And then you just fill it in. So this first box would be red one, green one. So if you rolled that box, you would have red one, green one. This one would be red two, that's still green one. Red three, still green one. Red four, green one. Red five, green two. I'm sorry, green one. Red six, green one. What would it be going across? I already have red one, green one. Going across the top, it would be red one, green two. Red one, green three. Red one, green four. Green five. Green six. And then you would just fill in the whole thing. I'm not going to make you fill it all the way in because I think it's pointless for you to write that, okay? So you get it, right? You understand how to do that. All right. So a probability model does more than just assign a probability. To each outcome. It allows us to find the probability of any collection of outcomes, which we call an event. So basically all we're doing is vocabulary right now. Okay, we've not done any work. It's just vocabulary. So no sample space, no outcomes, no probability models, no events. Okay, so here's an event. Is any collection of outcomes from some chance process. That is, an event is a subset of the sample space. Events are usually just designated by capital letters like A, B, C, and so on. And we'll get through all this. So an event would be rolling just like this. If I pick this, rolling a red 5 and a green 1, or a red 5 or a green 1. So and an or are going to come into play as well, the difference in those. Okay, so that's what we're getting into. But again, all this is right now is vocabulary. We've not done any work. If A is any event, we write its probability as P of A. In the dice rolling example, suppose we define event A as the sum is 5. What's P of A? The probability that event A occurs. All right, so how could we get the sum is 5 on that last chart? What are ways that we could get the sum is 5?
Red 2, green 3.
Red 2, green 3. What else?
Red 3, green 2.
Red 1, green 4. Anything else? Nope. So there are 4 outcomes in event A. Because each of these outcomes has a probability 1 out of 36, how did I get that? 1 out of 36.
6 times 6 outcomes.
Yep, 6 times 6. So that chart had 36 boxes we would have filled in. The probability of A is 4 out of 36. So we have 4 chances out of the whole chart to get that. Now consider event B, where the sum is not 5. To find the probability of B, or P of B, we could list all the outcomes that make up event B, but that would take a while because that would be how many other ones? 32. How'd you get that? So fortunately, there's an easier way. Of the 36 equally likely outcomes, event A, sum of 5, occurs in 4 of them. So event A does not occur in 32 of these outcomes. So the probability of B, or the sum isn't 5, we can call this the probability of not A. That would give us 32 out of 36. Then realize that if we added both probabilities of A and B, we would get 1. That'll come in handy in just a few minutes, okay? All right, let's consider one more event, which we'll call C. The sum is 6. What are the outcomes in the event C? Red 3, G3. Red 4, green 2. What'd you say? Other way around. R2, G4. What else? How can I get a sum of 6? R1, G5, and R5, G1. So that's the only ways that we can get that. So the probability of C is what? 5 out of 36, yeah. And you don't have to reduce them, it doesn't matter. What's the probability that we get a sum of 5 or 6? 5 or 6. That is the probability of A or C. Because these two events have no outcomes in common, we can just add them. Okay, one more time. They have no outcomes in common. So we just add them up. So we're doing the probability sum 5 or 6 is the same thing as the probability of the sum of 5 plus the probability sum of 6. What was our probability to get 5? 4 out of 36. 6 was, which gives us a total of 9 out of 36. And don't reduce them, just leave them alone, okay? In other words, the probability of A or C would be the probability of A plus the probability of C. So we just add them. All right, so there are some other basic rules of probability, and the first one is probability of any event. is between 0 and 1. We already knew that. All possible outcomes must have a probability that adds to 1. So there should be 100% total. This one's a long definition. If outcomes in the sample space are equally likely the probability that event A occurs can be found by the formula probability of A equals the number of outcomes in event A over the total number of outcomes in the sample space. Give me a minute to write that down. I just call this what you want over the total. Okay, so I'll make it kind of simple. What you want over your total. How did we find the probability that not 5 occurred, not a sum of 5? What did we do? That's the next one. The probability that an event does not occur is 1 minus the probability it does occur.
Can you slow down for just a second?
Yep.
Okay.
Y'all good? All right. Last one is the one we just talked about. If the events have no outcomes in common, then you just add the probabilities. We have the next page front and back, the check your understanding, and then we're going to stop this Zoom and then we'll start the next one. So that's where you're at.
So we got more pages left in stock.
We're doing 2 sets today. Okay. All right. You need to know the definition. This one, especially 2 events A and B are mutually exclusive. What's it mean to be exclusive? Or disjoint? What's it mean to be exclusive? Just in general. Like if you're dating somebody and you're exclusive.
You're only gonna make up.
Yeah, you don't date anybody else. There's no overlap. Y'all understand what I'm saying? So disjoint means that they're not connected. So there are no connecting factors. If they have no outcomes in common and so can never occur together, that means the probability of A and B happening, if they are disjoint, they do not overlap. So there is absolutely no way A and B can occur together. So it's going to be 0. So we can summarize the basic probability rules more concisely in symbolic form. So we're doing the same thing that we just listed. I'm going to make it a lot shorter though, okay? So in this form, for any event A, it said the probability has to be between 0 and 1. It's exactly what we wrote on the other page. So this page is no different than what we just did. If S is the sample space in a probability model, the probability of S, so the entire sample space, should have a probability of 100%. In the case of equally likely outcomes, the probability of A is what you want over the total. So again, what we wanted a minute ago was the sum of 5, right? We said that there were 4 of them. So that was what we wanted, 4 of them, over the total amount of squares was 36. Number 4 is called the complement rule. Bear with me when I write this. I'm trying to give you a little break here for a second. See that little C up there, A complement. That means not A. Okay, so if you need to write that down somewhere, A with a little C means not A. To find it, remember we did 1 minus the probability of A. If A and B are mutually exclusive, what does that mean? They don't overlap. Then the probability of A or B, because they don't overlap, is just adding them. And we'll talk about what happens when they do overlap. And there's actually not a 6 here, so get excited. You're done with that. The earlier die rolling example involved equally likely outcomes. Here's an example that illustrates the use of the basic probability rules when the outcomes of chance process are not equally likely. All right, so everybody got this page? Yell at me if I need to stop. This page in the front of the next, and then we'll stop this Zoom, and then we'll start another one. And those of you that are Zooming, if you want to go on and do your homework, that's fine. I don't think I've opened it yet, though. Everybody else sitting in here, you're going to have to do the second one. Sorry. You guys can watch the second video if you want, or you can join our Zoom. All right. Distance learning. Distance learning courses are rapidly gaining popularity among college students. Randomly select an undergraduate student who is taking a distance learning course for credit and record the student's age. Here's the probability model. Show that this is a legitimate probability model. How do we know that it's a probability model? Remember, the probability of the sample space has to add to 1. Everything has to equal 1. So we're going to look at all our probabilities. That's the bottom row. And we're going to make sure they equal 1. So how do we do that? We just add them. Perfect. This is on your test, I'm pretty sure. Okay. So this should be an easy question. How do you know it's a legit probability model? They should add to what? They do. Add to 1. People miss that question. You'd be surprised. No, it won't be. All right. Find the probability that the chosen student is not in the traditional college age group 18 to 23 years. So this is what we want to write. You need to make sure that you define everything. Okay. So we said the probability that this student is not 18 to 23. So how do we do knots? What did we say? Or the complement? 1 minus, right? So what we're going to do is find out how many are between 18 and 23. And then we're going to figure out the ones that are not. So we're going to do it 2 ways. Okay. The first way, because you have this cute little model you can look at, we don't want to include 18 to 23. So we could add them. Or we could use the complement rule that says we just subtract out the ones that are. Either way, they both give you 0.43. I don't care which way you do it. Both are the correct way. Got it? But if you had 50 of these numbers, you see what I'm saying? Like these are easy because there's only 3 to add up. But if you had like 50 of them, you definitely don't want to add the 50. You want to do the subtraction. I don't care which way you do it. Both are correct. All right, flip it over. Choose an American adult at random to find 2 events. A is the person has cholesterol level of 240 milligrams per deciliter of blood or above, which is high cholesterol. Or B, the person has a cholesterol level of 200 to 239 milligrams per deciliter, which is borderline high cholesterol. According to the American Heart Association, the probability of A is 0.16 and the probability of B is 0.29. So you need to remember those, okay? Explain why events A and B are mutually exclusive. Can't have both what? Yep. A person can't have both. You need to be specific. 240 or above. And 200 to 239 milligrams per deciliter at the same time. So those will never overlap. It's one or the other. That's it. Question 1, done. Don't make it harder than what it is. Here's what you guys have a problem with. Say in plain language what the event A or B is. What is the probability of A or B? So what does it mean? It means just state it in context. What is A or B? What is A? It's defined up there for you. Don't make it hard.
The person has a cholesterol level.
Yep.
of 240 milligrams.
So you're just plugging in the context for A. A says the person has 240 milligrams per deciliter or above. Or, this is the or in the problem right here. What was B?
Person has a cholesterol level of 200.
They have 200 to 239 milligrams, per deciliter. Then it says find the probability. You guys have a really hard time of reading the rest of it. Okay, so now you have to find the probability. What is the probability of A or B? Do they overlap? Do they overlap? No. So all we have to do is add it up. What's the probability of A? 0.16. What's the probability of B? 0.29, which gives you a total of 0.45. If C is the event, this is number 3. If C is the event that the person chosen has normal cholesterol, which is below 200, what is the probability of C? How would I find that? 1 minus 0.45. Why can I do that? Yeah, so they either have normal, borderline, or high. There's nothing else they can have, so that's your 100% of what you can have. And then we don't want high or borderline, so we're gonna take that out, and we get 55% have normal. And that is it. All right, I'm gonna end this Zoom, so I'm gonna stop share, stop recording.